in lesson 66, what we're talking about is the area formula for regular polygons. I'll make sure that I actually get back. Here we go. Finding the perimeters and areas of regular polygons. So we're going to be talking today about being able to find the area of different shapes than what we've found before. Up to this point, we found the area of triangles, we found the area of circles, trapezoids, rectangles, squares, a lot of different areas. We've done surface area, and we've done all that. Okay, but today we're going to talk about not necessarily things that are abstract, but things that are a little bit more complex, things that have more sides than just a quadrilateral. So far we've done circles, which is not a polygon, we've done triangles, and we've done quadrilaterals. So we've only really found the area of things that have either 3 sides, 4 sides, or an infinite number of sides, but we've not found anything that, let's say, has 5 sides or 6 sides, something like that, okay? And there's actually a specific way to do this given that they are regular. Can anybody tell me what a regular polygon is? What's the definition of a regular polygon? They have 2 things, 2 attributes. Go ahead. Okay, all sides are equal or congruent. Congruent's the right word there. And all interior angles are congruent to each other. Okay, so we have those 2 things. So we can really come up with any kind of polygon and find a regular or irregular. These are all going to be based upon regular polygons, and we're going to understand for a second why that's going to be important later. The center of a regular polygon, that's going to be important to us. The center of a regular polygon is a point within each regular polygon that is equidistant from all of the vertices. Okay? Vertices as opposed to sides. So you're going to be drawing it to a point, not a side. Okay? That's going to be the center. Okay? Everybody good so far? All right. Again, all of this is in your book. You could find it all there. And then we've got central angle. Central angle comes from the center point. Okay, central angle of a regular polygon is the angle whose vertex is the center of a regular polygon. We first started talking about central angles when we were talking about circles. Now we're going to apply them to polygons. Okay, it's this the angle whose vertex is the center of a regular polygon and whose sides pass through consecutive vertices. Okay, consecutive vertices, meaning vertices that are in order next to each other. Okay, so it's an angle that goes to consecutive vertices that comes from the center of the regular polygon. Okay, and this is going to have a specific, because we're talking about an angle, it's going to have a specific angle. Okay, and the way we're going to find that specific angle is we're going to count the number of sides and we're going to divide it by 360. Okay, we'll do that later on. We'll see why that's important. So in this case, if I want to know what that angle is, I'm going to take 360 degrees because if I go all the way around, inside of that, it forms a complete circle. If I want to know what this angle is right here, it's going to be 1/5 of the entire circle. Does that make sense? Yes? No? Wobble our heads up and down if we understand what I'm saying. All right, thank you. I understand we get to second period and nobody's ready to talk yet. Okay? All right. So that's going to be important here a little later on. Okay? And then we have a new term. Okay? A new term, not a word that we use a lot, not a word that you probably have even heard up to this class. Let's see, we're in geometry, which means many of you haven't had Algebra 2. But is apothem a term that you're familiar with? Okay, we're going to wobble our heads back and forth. No, this is a new term to us. Apothem is a perpendicular distance from the center of a regular polygon to a side. So it has to be perpendicular, and it has to go from the center to a side. Okay, this distance right here is referred to as the apothem, or lowercase a. Capital A is reserved for area, lowercase a stands for apothem. Okay, and apothem is a distance. Again, it's a distance that goes from the center of a regular polygon, okay, to the perpendicular point on a side. Okay? All right. And we're going to use that distance to be able to find the area of a regular polygon. Okay? Apothem times the perimeter divided by 2 is going to be my area, or 1/2 times AP. Okay? So it's no more complex than, say, finding the area of a triangle, right, which is base times height divided by 2. It's pretty much the same formula. You could look at it as AP divided by 2, but A is a little bit harder to find depending upon what information I'm working with. Okay? So area of a regular polygon can be found by finding the distance from the center to the perpendicular of a line, okay, or perpendicular of a side, times the perimeter. Now keep in mind, if it's a regular polygon, right, the perimeter, all the sides are going to be the same length, correct? So if they give me, let's say they give me one side length, I'm going to need to multiply by the number of sides there are to find my perimeter. Okay, and I think that is it for that. So we're going to move over, let's see, not that, but let me find my lesson 66. Okay. I think we have 8 questions to look at. We'll get through as many of them as we can. All right, question number 1. It says, what is the area of an equilateral triangle with side lengths of 6 inches? I'm going to solve this not necessarily using apothem, but just what we know about equilateral triangles. Okay? I'm going to try to draw an equilateral triangle here. It's not too bad. What's the area of an equilateral triangle with side lengths of 6 inches? Okay? So if this is 6 and this is 6 and it's equilateral, right, which means it's also equiangular. Okay? An equiangular triangle has angles that measure what? 60 degrees. I'm going to create a perpendicular line, and so that whenever we're finding the area of a triangle, we're doing base times height divided by 2. What is the base of that triangle? 6. Okay, I need to find the height of the triangle. Okay, at this point, whenever I split that, this became a 30, 60, 90 triangle. Can anybody tell me what that's going to be? What would happen to that base with that perpendicular line? Divides it by 2. What's 6 divided by 2? 3. So if my 30 is 3 and my 90 is 6, what's my x? 3 radical 3. Okay, so I have 3 radical 3 times 6 divided by 2. What's 3 times 6? 18. So I'm getting 18 radical 3 divided by 2. What's 18 divided by 2? 9, so I get 9 radical 3. That's not the only way to find that. You don't have to know your 30, 60, 90s to do that. I could have also solved this using Pythagorean theorem. 3 squared plus b squared equals 6 squared, right? And I still would have gotten 3 radical 3 here. I still would have gotten 18 radical 3 divided by 2. I still would have gotten 9 radical 3 inches squared. Okay, does everybody understand how we could have used the Pythagorean theorem to find the height of that triangle? Okay, I'm getting most people shaking their head up and down. All right, number 2 is where we use this formula at. Okay, the whole apothem times perimeter divided by 2. And I don't like it looking yellow like that, so we're going to fix that. Okay. What I want you to understand first is that, how many sides does this have? It's got 6 sides. Okay, it's got 6 sides. Each side measures 4. Notice that this, they're saying that divides it into 2. Okay? I want to find out what this angle is right here. Okay, so what am I going to do? We talked about this earlier. How am I going to find that angle that has the arrow pointed to it? Let's look at this. All right, if I go all the way around, how many degrees is that? 360 degrees. Okay, what do I need to divide this by? 6, because it has 6 sides, right? So each one of those triangles that I would make, I could make triangles that went all the way around that are going to split this, right, into that 360 degrees into 6 equal parts. So what's 360 divided by 6? 60 degrees. Okay? So now I know that this, let's use different color here, is 60 degrees. And what I have here is a right triangle, correct? Which means this angle what? No. If this is 60 and this is 90, 30. It's a 30, 60, 90 triangle, correct? Okay? If this is 2, what is my hypotenuse of that triangle? 4. Okay? Because it's going to go x, 2x, x radical 3, right? But x is 2, so what is my apothem? What is this line right here? 2 radical 3. Okay, so now I know that my apothem is 2 radical 3. What was my formula for finding the area of this? Okay, if one side of this measures 4, how am I going to find the perimeter? What is 4 times 6? 24. So I've got my perimeter. We said that my apothem was 2 radical 3. Let's divide by 2. Well, what's 2 radical 3 times 24? What's 2 times 24? So I'm going to get 48 radical 3 divided by 2. Well, what's 48 divided by 2? 24 radical 3, right? Can I plug that in my calculator? Okay, we want it to the nearest tenth. What's 24 radical 3? I'll let you guys figure that out. .6 because it's area, it's meters squared. Is this doable? Okay, follow the steps. Find out what that central angle is, right? And that's going to tell you what type of triangle you're working with. I'm going to tell you right now that most of these are going to be hexagons, and it doesn't, so long as I'm trying to find the area of a hexagon, that is always going to be 60 degrees because I'm always going to end up taking 360 and dividing it by 6. So this is always going to be a 30, 60, 90. Okay? Now, the numbers will change, but the ratio won't change. You see where I'm coming from? So if I knew that this was 6, that would make this 3. That would make this 3 radical 3. Right? And I'd automatically know what my apothem was. I'd take 3 radical 3. I'm going to take 6 times 4, or sorry, 6 times 6. So I'm going to get 36. So it's going to be 3 radical 3 times 36 divided by 2. You see where I'm coming from? So long as it is a hexagon, I'm going to solve it the same way every time. It might change if it's a pentagon, but other than that, it will solve the same way. All right, let's go down to number 3. Number 3, this is a lot easier. This doesn't actually involve finding an apothem. This is just a perimeter question, but you do see this question show up on a test. A jeweler creates triangle earrings by bending pieces of silver wire. Each earring is equilateral. What does the term equilateral mean? All sides are the same length. Each side of a triangle is 6 centimeters long. Okay, each individual side is 6 centimeters long. How many earrings can be made from a piece of wire that is 396 centimeters long? What do I need to do with 6? Multiply by 3 to find the perimeter or the total length of each earring, right? What's 6 times 3? 18. So I know that if I unbended each earring, it would be 18 centimeters length of wire. What do I want to do with 396? Divide it by 18. Or sorry, not a square root, just a division bar. 396 divided by 18, what does that equal? 22 earrings. I can make 22 earrings out of 396 centimeters of wire. Okay, people have a real tendency to make this question super, super difficult. It's not super, super difficult. Okay, you just have to look and see what the question is actually asking you to find. 4. Okay, notice that this doesn't give you a picture. Okay, it says find the perimeter in feet of a regular pentagon if one side measures 13.5 feet long. This is actually easier, right? It's a pentagon. Pentagon has how many sides? 5 sides. It says that it is a regular pentagon, which means each side is what? Equal to every other side. If one side is 13.5 feet long, and I want to find a perimeter. What am I going to do with 13.5? Multiply it by 5, the number of sides. So what's 13.5 times 5? 67.5 feet. Okay? Easy peasy, right? Don't make it more difficult than it has to be. The only time that this is going to be difficult is if they're asking for area, in which case it's going to take a few more steps. Perimeter in meters of a regular pentagon with sides that measure 1.7 meters. Is this any different than question number 4? No. Exact same process. 1.7 times 5 is what? 8.5. 8.5 meters, so we're going to label that 8.5 m. Now life gets a little bit more tricky for 6, 7, and 8. These are going to be based upon each other. 6 says, use the apothem to find the area of a regular hexagon with side length of 4. Now, I'm not going to spend a lot of time on 6, and the reason why is because, look at question number 2. Is that a hexagon? Does it have a side length that measures 4? So, am I going to get the exact same area? Yeah. It's going to come out exactly the same. So, it's going to end up being 41.6 meters squared. So we're not going to actually do question number 6 because it's the same thing. You could also write that as 24 radical 3. But let's look at number 7. Okay. Number 7. Mary is painting the floor of a gazebo that is in the shape of a regular hexagon. Okay. We've worked with hexagons. That's what number 2. That's what number 6 was. Okay. But it has sides that measure 8 feet. 8 feet. Okay, instead of 4, right? Okay, what is the total area that must be painted? So if I'm drawing a picture of this, I'm getting something that looks like this, where this is my apothem, okay, A, that's my side length, okay? So that's perpendicular. All right, what is this length right here? 4. What do we know that that angle is going to be because it's a hexagon? 60 degrees, which means this has to be 30, which means I'm working with a 30, 60, 90, okay? Which means what is my apothem? 4 radical 3, because it goes x, 2x, my a is x radical 3. If x is 4, then a is 4 radical 3. So do I know what my apothem is? Yeah, okay. Suffice does this say is if they give me a regular hexagon and they tell me what one side length measure, I'm going to take the side length, divide it by 2, and multiply it by radical 3. All right, you see how much quicker that is? All right, now I need my perimeter. How am I going to find my perimeter? 8 times 6, okay? My side length times the number of sides. What's 8 times 6? 48. And what do I need to do lastly? Divide by 2, because that's my formula. All right. So we have, what do we got there? What is 4 times 48? 192. So it's really 192 radical 3 divided by 2, right? What's 192 divided by 2? 96 radical 3 feet squared, and we can leave it like that if we want. Okay, I think on number 7 that's how they leave it. So 96 radical 3 feet squared. Is this easier than the way that it sounded at the beginning? Some of you Erica's giving me a look like, I don't get this. Do you not? Are you struggling with it? Okay. So whenever we get into the homework, ask me. We'll sit down. We'll do some more of these. Aaron, how are you doing? Pretty good. How many of us feel like we got a pretty good hold on it? How many of us are a little iffy? Are you more iffy or down? You're all the way down. Okay, so we'll work on some more. Okay, and find the area of an equilateral triangle with side lengths that measure 48. Okay, because it's equilateral, if side lengths measure 48, then I'm drawing that, right? Okay, area is what times what divided by what? Erica, what's the area of a triangle? Base times height divided by 2. So what is the base of this triangle? If all my side lengths measure 48. 48, okay? All right, we do need to find the height though, okay? Because this is a equilateral triangle, it means it was originally all equiangular, right? So if I draw this line, what happens to that angle? It becomes 30. It gets divided by 2, right? Okay? So it's a 30, 60, 90 where, what's this side length now? If this was 48 and I drew this line, it becomes 24. Okay? Notice that all we've worked with so far is just 30, 60, 90 triangles over and over and over again. All right? My height of this triangle is that side right there. Okay? So x in this case is 24. Okay? My hypotenuse is 48. Can you tell me what x is going to be? Perfect, 24 radical 3. Okay, so my height is, okay? So it's the exact same thing that you're doing with your hexagons, right? Okay, except we're just doing a right triangle. We're just doing a 30, 60, 90 triangle inside of a hexagon. Okay, so we've got 24 radical 3 times 48 divided by 2. What's 24 times 48? 1,152 radical 3 divided by 2. What's 1,152 divided by 2? So I get 576 radical feet squared. Or sorry, this is in meters squared, isn't it? Square meters, or meters squared. Okay, does that help you out a little bit? Do you feel better about the hexagons now? Because that's all you're doing pretty much over and over and over again. Now, later on, we might work with pentagons and some of the other shapes, but I think largely today, it's mainly hexagons, so that you're getting used to using 30, 60, 90s, and your height of that is your apothem. Okay? All right, any questions before I close out? None? Okay.